Hi students, in the previous video we have seen about acids, their properties and their reactions and their uses. Now we will see about bases. In this video let's talk about bases. A general study of bases. Now what are bases? Bases are oxides or hydroxides of metals. It may be an oxide, it may be a hydroxide of metal. Now there is one base which is not having a metal, that is ammonium hydroxide. It does not have a metal ion in it. Otherwise all bases are oxides or hydroxides of metal. Bases soluble in water are known as alkalis. Example, NH4OH, ammonium hydroxide is a base and also alkali because it is soluble in water. Now potassium oxide, potassium hydroxide, sodium oxide, sodium hydroxide, calcium oxide, calcium hydroxide, all these are soluble in water. They are soluble. So in water. So they are bases as well as alkalis. Bases as well as alkalis. Now the metals below this, from magnesium to this, whatever is below in the activity series, these metal oxides and hydroxides are insoluble in water. Insoluble in water. So they are bases but not alkalis. Okay. So all these are bases, but only ammonium hydroxide, potassium hydroxide, sodium hydroxide and calcium hydroxide. Only these four are alkalis because only these are soluble in water. The remaining are only bases, they are not alkalis. So you can say, according to Arrhenius theory, an alkali is a substance or a compound which when dissolved in water yields hydroxyl ions as the only negatively charged ions. Now NaOH, if you dissolve NaOH, hydroxyl ions, it will dissolve in water plus H2O, it will give Na plus OH minus ions, OH minus, and also H plus and OH minus. So OH minus ions are the only negatively charged ion formed here. If you take NaCl, NaCl plus H2O, it will give Na plus ions, yes, plus Cl minus ion, OH minus ions and H plus ions. Okay. Now Cl minus is another negative ion. The definition says hydroxyl ions as the only negatively charged ions. Now since chloride ions are also formed as another negative ion, so this is not an alkali. Even though hydroxyl ions are produced, but this is alkali. Sodium hydroxide is alkali, sodium chloride is not alkali because it produces another negatively charged ion. Alkalis which liberate heat energy when brought in contact with water are known as caustic alkalis. Example, sodium hydroxide and potassium hydroxide. They produce heat. If you touch them with moist skin and your skin will be burnt, they are caustic. Alkalis are classified as strong and weak alkalis on the basis of their strength. We can classify them. The strength of an alkali is determined by the amount of hydroxyl ions it produces in 1 liter of its solution. Now that determines. So if it produces more hydroxyl ion, it will be stronger. Less hydroxyl ion, it will be weaker. Now strong alkali dissociates almost completely. Almost all molecules will dissociate. It will produce high concentration of hydroxyl ion in aqueous solution, and therefore it is a strong. Example, sodium hydroxide and potassium hydroxide. Now weak alkalis, they dissociate partially in aqueous solution and they produce low concentration of hydroxyl. All the molecules will not dissociate, so concentration of hydroxyl ion produced will be very less. Example, calcium hydroxide and ammonium hydroxide. These are weak alkalis. Now let us understand the other classification of alkalis. Alkalis may be classified as dilute and concentrated depending on their concentration amount of water. A dilute alkali contains large amount of water and small amount of alkali. Since there is large amount of water, it undergoes a greater degree of dissociation and it produces greater amount of hydroxyl ion. So it is a stronger form of the alkali. Okay. Concentrated alkali contains small amount of water, large amount of alkali. The dissociation is poor here due to lack of sufficient amount of water. Therefore, it contains less amount of hydroxide and therefore it will be weaker than the diluted form. It is weaker than diluted form. Now we also have bases classified as monoacidic, diacidic and triacidic on the basis of basicity. On the basis of their acidity, not basicity, acidity. Now the acidity is the number of hydroxyl ions produced by one molecule of the base in its aqueous solution. Yes, acidity is also defined as the number of hydrogen ions with which one molecule of the base can combine. This is another way of defining it. Example, NaOH. It will dissociate to give Na plus and 1 OH minus. KOH will give K plus and 1 OH minus ion. NH4OH will dissociate to give NH4 plus and only 1 OH minus ion. One molecule gives only 1 OH minus ion. So the monoacidic bases, or in other words, acidity is equal to 1 monoacidic bases. Now we also have the diacidic bases. In the diacidic bases, calcium hydroxide dissociates to give Ca plus plus and 2 OH minus ions. MgOH whole twice gives Mg plus plus and 2 OH minus ions. CuOH whole twice gives Cu plus plus and 2 OH minus ions. So the acidity here is 2. So we can call them diacidic bases. Triacidic bases will dissociate to give 3 OH minus ions per molecule. 3 OH minus. Yes. Fe plus 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 and 3 OH minus ions. So the acidity here is 3. So that is triacidic bases. So students, I hope you understood the general characteristics and general study of bases. So please subscribe and like the channel. In the next video, I will discuss about properties and characteristic reactions of bases and their uses. Thank you.